Welcome to Sweden. Welcome to Malmö. We are exceptionally proud to introduce to you today a major addition to our toolbox, the Starmix Nova. Before jumping into the really juicy stuff, we at Höganäs want to extend our sincerest gratitude to two of our loyal customers, without whom we would not have been able to present this today. So a big thanks from Höganäs to FJ Industries and Gevorkian. Thank you very much. And with that, it's movie time. So what you see in front of you is the bread and butter composition in the PM industry, which is the iron copper carbon. On the right is a premix. It's flowing quite erratically. It's a rat hole forming. And the Starmix Nova is exhibiting a much more smooth mass flow performance. And it's the same amount of material, of course. And the Starmix Nova passes, this is the Hall flow test, in 27 seconds. Whereas the premix is still kind of working.
Still tries to flow.
Yeah. And again, the premix with amide wax, that is what most of our customers are using. And today I hope that we can show to you why it would make sense to actually go for the Starmix Nova.
But did you know what this reminded me? Did you see on the left side? It was flowing like water. There is a quote, "Be water, my friend." Who knows from whom that is? Who said so? He gets the first flex back for free. Be water, my friend. That was from Bruce Lee, philosophizing his martial art. But I'm quite sure my colleague who developed this product, he was not thinking about Bruce Lee. He was thinking about flow. So thank you very much to the colleague.
So one of the best features with Starmix Nova is the high apparent density with the combination with a very fast flow. And here we can see that the apparent density is much higher than the premix with amide wax and even higher than premix with zinc stearates, which is what people normally use when they need the high AD. And with that...
Yes, Fredrik, let's translate this into some figures which the customers are using. Filling factor. Amide wax, 7.0 density, 3.0 apparent density gives a filling factor of 2.33. For Starmix Nova, 3.3 apparent density, 7-point density, we have a filling factor of 2.12. Difference 2.1 gram per factor of 2, which means for 10 millimeters, I have 2 millimeter lower tool height. For a 30 millimeter component, this ends up in 6 millimeter shorter toolings. Saves cost, improves rigidity and tolerances. So you directly get a benefit from the high apparent density just from a tooling point of view. So what else, I wonder, comes with the product, Fredrik?
Well, thanks for asking, Christophe. As you saw in the flow video, you could see that the Starmix Nova was flowing much better than the premix with amide wax. But again, some customers are still using the zinc stearate. And in this case, the Starmix Nova would perform even better. And I want to show that to you. And what happens then is that you can fill your tools faster. You will have a shorter filling height. You will have more robust toolings. You will have higher productivity. But there is something missing. Right.
Yes, how does it look in real life?
How does it look in real life? Thank you, Christophe. So this test we did together with Gevorkian. You can see the component on the top right side. And the orange, throughout the presentation, the Starmix Nova will be orange. The current premix is blue. And you can see the sigma numbers here. And this is weight scatter. It's a relatively small part. The teeth are relatively small. It's difficult to fill this tool. And it has a fantastic weight scatter for the Starmix Nova. It's 35% better than the current premix. And this is a Höganäs premix that we made with a lot of love and care. So it's not a bad comparison. I also want to stress that Both these are done at exactly the same stroke rate. But of course, we did trials at Gevorkian where we actually tried to increase the stroke rates. And those numbers we keep to Gevorkian and to ourselves. All I can say is that they look bloody good. So.
Oh yes, also very important.
The compressibility and the green density, how does it look? Well, let's start with the benchmarks. Starting with the amide wax is a 0.8 iron copper carbon with 0.8 amide wax or 0.9 zinc stearate. This is pressed at 700 or 800 megapascals respectively. How does the Starmix Nova with 0.6 lubricant hold up? This is how it looks. So it's a significant improvement, even though the lubricant content is better.
This is a lubricant content difference.
There is. But the interesting thing is that we can remove even more lubricant. Actually makes the mix cost less. And you get higher density. And I like that. Sounds like a win-win to me. We can go even further. So we can go down to 0.4, which is half the amount what you have with the amide wax mix.
But you are confusing me. Why are you making such comparisons? They are completely nonsense.
No,
lubricant content to lubricant content. Please.
Yeah, yes, you're right. We need to talk about the ejection. Can we get the parts out of the die?
Yeah, that I would like to see, yes.
Yeah. So let's start again with the premix with amide wax and the premix with zinc stearate. And the ejection energy is the amount of energy you need to eject the component from the tool. You want that to be as low as possible. Then you have really, really good lubrication. So let's start with the 0.6. You can see how efficient lubricant this is.
That looks good.
But the question to me is, can we match this ejection energy from the amide wax and zinc stearate when we go down in lubricant content? Let's find out. So 0.5, we're getting closer, right? But even at 0.4, meaning half the amount of lubricant, we still have better lubrication than with amide wax. So it's an enormously efficient lubricant.
Now the comparison makes sense. But I mean, this is like with 0.6 is 30% better ejection energy or lower ejection energy. So that must be great.
It will be less friction in the tool, less heating of the tools, and faster production. We made a test in-house for larger runs, actually, just to see how the weight scatter worked out over larger series. And then again, we start with the amide wax. You can see how the flow behavior, when it's really flowing erratically, translates to really bad performance in the weight scatter. Comparing that with the zinc stearate, and again, the reason the zinc stearate is higher in weight is, of course, that the apparent density is higher. But the Starmix Nova has even higher apparent density. And you can see that if you compare Starmix Nova with the zinc stearate, the improvement is 30%. In weight scatter. And if you compare it with amide wax, it's 50% better. And all this translates...
Hold on. Now we are comparing amide wax and zinc stearate. But, I mean, zinc stearate is dirty.
Yes.
Amide wax is clean. What's with Loop Nova?
It's very clean.
Cleaner than clean?
Yes.
Okay.
It's like water.
Purified water.
Exactly. So to conclude, what do we have here? We have a great product that we are very proud to present to you, the Starmix Nova, with very high apparent density, very fast flow, where you can increase your productivity. And when you reduce the filling height, you fill faster, you can actually increase the press rates and make the toolings more compact. This leads to improved consistency, as you can see, lower weight scatter, green scrap reduction, and very clean burn-off, to your point.
Come on, where's the buck in it? Can we deliver?
Yes.
Come on.
We have ample capacity, and we can deliver Starmix Nova in all markets worldwide.
This is too nice.
I know. So here we have the payoff, and I would like to say that we have the data sheets in the booth. Please, when we're finished, step over to the booth, grab a data sheet, talk to us about this. And like migrating birds, we are all leaders. Let's help each other to reach the destination. And let's go with the flow. Thank you for your kind attention. Do you have any questions?